Let's now see how we can represent the bonding in three different molecules, ethane, ethene, and ethyne, which is given by the formula C2H6, C2H4, and C2H2. Now notice that the first thing we need to do is draw the Lewis structure and determine the electron geometry of all the central atoms. So I'm going to draw them at the top. This is the Lewis structure for C2H6. If you don't recall how to draw Lewis structure, you can look back at the video on Lewis structure. This should be the Lewis structure for C2H4, and this would be the Lewis structure for C2H2. Now, in each of the structures, we have two central atoms. They're both carbons. So I've labeled the central atoms 1 and 2 there to differentiate them. Now, both central atoms in C2H6 happen to be tetrahedral central atoms, so they have 4 pairs of electrons around them, 1, 2, 3, and 4. And so that automatically means that they're going to use sp3 hybrid orbitals. If you go to the C2H4 molecule, you'll notice that both carbon atoms have trigonal planar, which means there's 3 pairs of electrons around the central atom. 3 pairs means that it's going to use sp2 to make its sigma bonds. And then lastly, when we look at C2H2, we notice that it's a linear electron geometry, which means that it has 2 pairs of electrons, 1 and 2, and that means it's going to use the sp hybrid orbital. Now, it's important to note that not in every example you would have the same central atom in the molecule. Sometimes one central atom might have tetrahedral geometry and the other central atom might have trigonal planar geometry. That actually happens quite often. So this is just an example where both central atoms happen to have the same electron geometry. So let's draw this out. So the drawing here shows first 2 carbon atoms. I'm going to point to the 2 carbon atoms. They have 4 lobes, all colored in black. Those 4 lobes are representing the sp3 hybrid orbitals for each carbon atom. Now there's a carbon-carbon bond, which is highlighted by the arrow in green. That is a result of the sp3 overlap. So that's a sigma bond that you want to keep in mind. Then I drew the 1s orbital in red, representing the 6 hydrogen atoms. And so if I tally up all the bonding, I'm going to have 6 carbon-hydrogen bonds, which is sp3 1s overlap, 1 carbon-carbon bond, which is an sp3 overlap, resulting in a total of 7 sigma bonds for this molecule. If I go to C2H4, now I have to use sp2 orbitals, and sp2 orbitals, if you recall, has 3 lobes oriented at 120-degree angles from each other. So that's what I drew there in black for each carbon atom. Now notice that as illustrated by that green arrow, there is an sp2 bond which happens between the 2 carbons. So that's a sigma bond. The hydrogen again is illustrated as red circles representing the 1s orbital. And then don't forget, in sp2 hybridization, there's 1 p orbital that is unhybridized. That p orbital is represented in yellow color here, and in that p orbital there's 1 electron that's left, and that electron is what's going to make the 2p2p pairing to form the pi bond, which is the double bond that we see in the Lewis structure of C2H4. So then the way we explain the structure using the valence bond model is that there is 4 CH bonds, which is sp2 1s overlaps. There's 1 carbon-carbon sigma bond, which is an sp2 overlap. There's 1 more carbon-carbon bond, but that one is a pi bond, which is a 2p overlap. So in total, we have 5 sigma and 1 pi bonds. Let's take a look at C2H2 now. For this one, remember, we're going to use the sp hybrid orbital to represent the carbon atom. So sp, as you recall, is a linear structure with 180-degree separating the 2 lobes of the sp hybrid orbital. So they're drawn in black again for the carbon atom. And again, with that green arrow, I'm showing the sp overlap between the 2 carbon atoms. So that's the sigma bond. The red circles represent the 1s orbitals coming from hydrogen. And now with sp hybridization, you have 2 unhybridized p orbitals. They are represented in the drawing by the yellow color orbitals and then the blue color orbitals. So 1 yellow color orbitals, which is the p orbitals from 1 atom, is going to pair up with another one from the other atom, forming 1 pi bond. The blue one is also going to do the same, and that would form the other pi bond. So in total, if we explain the bonding, it's going going to be two carbon-hydrogen bond, sigma bonds in this case, and that's a result of sp1s overlap, one carbon-carbon sigma bond, which is a result of sp-sp overlap, and then you have two carbon-carbon pi bonds, and both of these pi bonds are a result of 2p2p side-to-side overlap. And so in total, we have three sigma bonds and two pi bonds in the structure of C2H2. I want you to think about how to draw the structure for CO2 using the same ideas that we developed in this question. One thing to note here is that oxygen formed enough bonds that it actually uses also hybrid orbitals. So you have to think about what hybrid orbital oxygen, even though it's a terminal atom, will also use, and what hybrid orbital the carbon would use.